The Uncertainty Principle, how Heisenberg redefined knowledge. What if I told you that the moment you try to figure out exactly where you are in life, you'll immediately lose track of where you're headed? And no, I'm not talking about your last existential crisis at 2 a.m. over microwave lasagna. I'm talking about a principle of the universe so deeply baked into reality that even the tiniest particles are bound by it, and so maddeningly paradoxical that it makes horoscopes seem like a stable epistemology. Imagine you're watching a squirrel. Not just any squirrel, but a particularly caffeinated one zigzagging through a park like it's late for an acorn conference. You want to know two things: where it is and how fast it's moving. You grab a telescope, don't ask why, but as soon as you zoom in close enough to see the blur of its fuzzy little tail, you realize you've completely lost track of which direction it's darting in. Conversely, when you step back to see its motion, it becomes a smeared blob on the horizon. Congratulations! You've just stumbled into the living metaphor of quantum physics' most notorious party crasher, the uncertainty principle. Werner Heisenberg, the man behind this unsettling revelation, wasn't trying to write riddles for Zen monks or ruin your high school physics exam. He was, in the late 1920s, deeply immersed in trying to make sense of the increasingly weird behavior of particles at atomic and subatomic scales. Classical physics, with its neat rules and comforting determinism, like Newton's laws, which told us the planets would keep spinning predictably unless we did something very dramatic, had no tools to explain why electrons were acting like they couldn't make up their minds. Heisenberg's uncertainty principle states, in essence, that you cannot know both the exact position and the exact momentum of a particle at the same time. The more precisely you know one, the less precisely you know the other. Not because your microscope isn't good enough, not because the particle is particularly shy, but because the universe itself won't let you. This wasn't a case of technological limits. It was a feature of reality, not a bug. A fundamental trade-off. And just like that, the comforting idea that the universe is a vast machine with gears you can trace back to the Big Bang was replaced by a more honest and significantly more twitchy vision. A universe built on probability clouds, not certainties. Now, you might be tempted to think, okay, that's just for electrons and quarks and stuff. I'm made of meat and coffee. Surely I don't have to worry about this uncertainty nonsense. Well, you're right and wrong. The uncertainty principle is most noticeable at the quantum scale. That is, the very, very, very tiny. In the macroscopic world, the uncertainties are too small to matter much. You can't lose track of your car because its location and speed have a positional uncertainty of a quadrillionth of a nanometer. Unless, of course, your car is metaphorical and your life is spiraling, in which case the physics can't help you. But here's where things get deliciously weird. Even though the uncertainty becomes insignificant in our daily experience, the principles behind it don't go away. They're quietly humming in the background of your existence, shaping the behavior of atoms in your brain, the semiconductors in your phone, and the very nature of what it means to measure anything at all. In fact, without this uncertainty, many modern technologies wouldn't exist. Your GPS relies on quantum clocks. Your MRI scan operates on nuclear spin states affected by quantum rules. Quantum cryptography, built entirely on the impossibility of knowing certain values without disturbing the system.
Still, not everyone was thrilled when Heisenberg dropped this knowledge bomb. Albert Einstein, for one, was deeply unsettled. God does not play dice with the universe, he famously scoffed. He couldn't accept a world ruled by probabilities instead of ironclad laws. But Niels Bohr, Heisenberg's mentor and a fellow founding father of quantum theory, had a sharp reply. Einstein stopped telling God what to do. Their debates were legendary, the kind of intellectual brawls that make today's Twitter feuds look like squabbles over soup preferences. Einstein tried to poke holes in the theory with clever paradoxes, like the EPR thought experiment, which questioned how particles could influence each other instantly across vast distances, what he called spooky action at a distance. Bohr and his quantum crew parried these attacks, not by denying the weirdness, but by embracing it. The universe, they argued, is weird. Get over it. What's even more mind-bending is how the act of measurement itself becomes part of the system. In the quantum realm, the observer affects the observed. When you measure a particle, you're not just peeking into its diary, you're editing the entries. This raises philosophical questions that would make even Descartes do a double take. If reality depends on observation, what is reality when no one's looking? Does the moon exist when you're not staring at it? Spoiler, yes, but that's only because the moon is really, really big and decoherence has your back. And then there's Schrödinger's cat. Poor hypothetical feline, forever trapped in a box with a radioactive atom and a poison vial, simultaneously alive and dead until someone opens the box. It's not a lesson in animal cruelty, it's a metaphor for quantum superposition. The idea that particles and quantum states can exist in multiple possibilities at once until collapsed by observation. You might think this is absurd, but it's been experimentally validated with actual particles. In other words, the cat in the box joke isn't just philosophy, it's science, dark, slightly unhinged science. But let's go deeper. The uncertainty principle doesn't just limit what we can measure, it reframes what knowledge is. In classical physics, the universe was like a grand library. If you had time, tools, and tenacity, you could eventually read every book, know every fact. Heisenberg set fire to that library and said, some of these pages don't exist until you open the book. And when you read one sentence, the rest goes fuzzy. This has profound consequences for determinism, the idea that every event is the inevitable result of what came before. Laplace's demon, a hypothetical being who knows the position and momentum of every particle in the universe, could theoretically predict everything. Except now, thanks to Heisenberg, the demon is unemployed. No amount of intelligence can overcome the inherent ambiguity at the heart of the universe. This uncertainty ripples beyond physics. In biology, randomness in molecular motion underpins genetic mutation, without which evolution doesn't happen. In computing, quantum algorithms exploit uncertainty and superposition to process information in ways classical bits can't. In philosophy, the idea of unknowability challenges our assumptions about consciousness, free will, and the nature of mind itself. If thoughts are built on quantum particles, and those particles are fundamentally uncertain, then perhaps our minds are probabilistic. Are we, in some sense, quantum systems with agency?
And in culture, Heisenberg has become a kind of meme. Breaking Bad's Walter White chose the name Heisenberg for a reason, a nod to transformation, to unpredictability, to duality. One moment, you're a mild-mannered chemistry teacher. The next, you're a meth kingpin. A human wave function collapsing into something unrecognizably sharp. Still, some physicists argue that uncertainty is a limitation of our framework, not a feature of nature. Alternative interpretations, like the many worlds theory, claim that all possibilities do happen, just in different universes. In that view, measuring a particle doesn't limit knowledge, It just sorts you into the timeline where that particular outcome occurs. Somewhere, the other you is seeing the opposite result. Which raises a question: is uncertainty real, or is it just our inability to see the whole multiverse at once? And that brings us to the edge of our understanding, where mathematics and metaphysics shake hands awkwardly, where science admits that its bedrock is, well, a bit wobbly. But maybe that's not a weakness. Maybe it's a sign of humility, that even the most elegant equations must eventually bow before the chaos at the heart of things. So the next time you feel lost, metaphorically or literally, just remember, even the universe doesn't always know exactly where it is or where it's going. And it seems to be doing just fine. Or is it? That depends. On what, exactly? Well, that's uncertain. If you found this article intriguing, don't hesitate to like it. It's a small click that tells me you're into mind-bending topics like this one. Feel free to share it with friends who wonder why a cat can be both alive and dead in a box, or who just enjoy having their view of the universe delightfully upended. And don't forget to leave a comment. What do you think about uncertainty? Does it make you anxious, curious, or uncertain about yourself? Let's discuss, definitively or not.